What makes vertex form so great? Well, vertex form, it's in the name. It gives us the vertex of the parabola. So it's a quick and easy way to find that vertex. If you remember with factored form, we had to add up the x-intercepts, divide by 2 to find the average of the two, then plug it back in to get the y value. But if you're already in vertex form, your vertex is simply the opposite of the inside would be your x value. So if it's a minus, we shift to the right. If it's a plus, we shift to the left. So I just want to point that out. So if there's a negative on the inside, we go to the right. If there's a positive, we go to the left. And then over here, with the outer number, if it's a positive, we go up. If it's a negative, we go down. So you just got to be careful with those. But let's look at this first example. So if you look at this one, we have a plus 5. So we're going to go left 5. It's a little backwards. That's the only one that's backwards, the inside. So I'm going to go to the left 5. So 1, 2, 3, 4, 5. And then this is a positive 4. So I'm going to go up 4. So up 1, 2, 3, 4. And that's where I'm going to put, my vertex point. Right there. That's where this point is going to go. It's going to go right here. Now we have another point to deal with. So what should we do with this other point? Now my recommendation is plug in a number next to the x value here. So let me just write this one real quick. This is 5, negative 5, 4 for that point. Okay, so what we're going to do is plug in a number next to this. So we're currently at negative 5. So for my second point, I'm going to try plugging in a number next to it. So let's go with negative 6. Why not? So y equals, so we just need another point. We'll plug in negative 6. So I'm going to put y equals negative 2 times negative 6 plus 5 squared. Let me move this out of the way. Plus 4. And I should do this in a different color. I'm getting mixed up with that other green that I put. There we go, do it in purple. And so this will equal negative 2 times negative 1 squared plus 4. Negative 2 times 1. I mean, technically you can plug in any point, but the problem is it may not fit on the graph. So you want to pick something really close to where your vertex is currently at. And so that's going to equal negative 2 plus 4, which is 2. So negative 6, 2 will be the other point, which will be right here. So as long as you place the vertex point where it goes, your parabola should work out. It looks something like that. Do the same thing here. I'll just show you where the vertex goes. So the vertex goes to the one to the left, and then down 1, 2, 3. So the vertex goes here. Plug in a value next to negative 1, so you can plug in negative 2 or 0 to find that other point. Let's look at one with a fraction. This is really what I wanted to go over. So plus means I'm going to go to the left 5. So that would be over here, 1, 2, 3, 4, 5. And then down 2. So down 1, 2. So this is where my vertex point is going to go. And actually, let's do that in green. So let's find the other point. Where's the other point going to go? So the other point, remember how we picked one value away from it? This time, we're going to pick 5 values from it. So currently our vertex is at negative 5. So I'm going to pick 5 spaces, either to the left or to the right. 1, 2, 3, 4, 5. If I went 5 to the left, 1, 2, 3, 4, 5, it would be off this graph. So I'm going to pick right here, which is 0. So I'm going to plug in 0 and find out what we get. So y will equal negative 1 over 5 times 0 plus 5 squared minus 2. And then that's 5 squared minus 2. So 5 squared is 25. And then 1/5 of 25. 25 divided by 5 is 5. Negative times a positive is negative. So it'll be 0, negative 7. That'll be this other point. So just make sure the vertex gets placed here. Make sure this point is this one here. And it'll more or less fix the graph for you. So let's just talk about this one real quick. So we go to the right 6. So for the vertex, we go to the right 6 and then up 1. So the vertex goes here. And then I'm going to pick 3 spaces from the vertex. So you can go to the left or you can go to the right. I'll go to the left. 1, 2, 3. So I'm going to plug in a 3 and see what I get out. And I'll tell you why we're picking that many spaces. It's because notice the fractions work out nicely. 1/3 of 9. 9 divided by 3 is 3. Plus 1 is 4. So the reason why I'm picking this many spaces away, 3 spaces away, is because that's what's going to get rid of the fraction when we substitute it. If you just pick 1 space away, you're going to end up with a fraction. And we can't graph the fraction here on con. Even though technically the fraction will be correct, we just can't graph it there. So 3, 4 would be the other point, which would be right there.